Now, in the previous two sections, in 9.4 and 9.5, we were simplifying expressions. Now you can see in 9.6 that we actually have equations. So in the previous questions, we were looking at problems and trying to find out, let me just flip back one, we were taking an expression like, say, something like this, and we were writing in a form that was simpler, that would be possibly easier to plug numbers into. Now we're going to be solving an equation and actually figuring out what x is equal to in this problem. And there are a few different ways that we can actually set this up to solve. And I'm going to show you a technique that in which we are going to clear our denominators. So first thing I want to do is I do want to factor. So I'll rewrite the question over. And I factor that denominator. Now, this technique is you basically are going to multiply both sides by the least common denominator of all of your fractions. So I'm basically clearing my fractions by doing a multiplication. And I like to do this where I write one time. You can multiply this side by something, multiply this side by something, but I'm going to put one big huge bracket around the whole problem, and I'm going to multiply by the least common denominator of all my fractions. So I know I need an x minus 3, and I know I need an x plus 3. That's my least common multiple, or the least common denominator for this situation. Now, I have to be careful. I need to distribute this to every term. So I am literally multiplying the left side of the equation by this factor and the right side. And I'm not multiplying by 1. Because this is an equation, I am allowed to multiply through both sides by the same number, and I'll make an equivalent equation that will just be easier for me to work with. So be careful about reducing. So at this point, if I distribute these two factors to the left side, the x minus 3 will cancel out, and I'll be left with 1 times x plus 3, which is x plus 3. Now when I distribute to the right side, the x plus 3's cancel, the x minus 3's cancel, and the only thing I have left is a 6x. So I have cleared my denominators by multiplying through both sides by this least common multiple, or least common denominator of all my fractions. And so then I'm going to subtract x from both sides, and then divide by 5. Be careful not to divide by 3. And so I get my solution. The one number, the only number that makes this equation true that I can plug in place of x is 3/5. And I went through and checked. I did a little check off to the side, and I actually have already checked this myself. If I take 1 divided by 3/5, which you could even put in a calculator as 0.6, and when I do that, I get negative 0.141 with the 6 repeating. And my question is, does it make the other side to be the same thing? If I take 6 times 3/5, which again is 0.6, and divide it by 3/5 squared minus 9, double check, and it actually does give me exactly the same decimal. And so remember, we can use that checking technique on our calculator, where we could literally go on our calculator and take the fraction 3/5, and we could store it as x. And then I could check my left side, 1 divided by left parenthesis x minus 3. And I could check my right side, 6x divided by left parenthesis x squared minus 9. And I'm good to go. All right, so we can, and I probably would let you have a calculator. Although we didn't really need any calculator to do this, it is nice to check them with a calculator. Now, next one. You can see I'm going to use that same technique. I'm going to multiply through. My denominator is already factored for me, and I want to clear my denominator. So I can see that I need to multiply everything, both sides, by a 5, and I need to multiply both sides by x plus 2. Okay, and I can do this multiplication. I don't have to multiply by 1 because I am multiplying both sides by this, and the multiplicative property of equality says you can multiply both sides of an equation by anything you want. So when I distribute this 5 times x plus 2 to the left side, the 5x plus 2, and that cancels out, and I have negative 4 on my left side. On the right side, My x plus 2 cancels that x plus 2, and I have 3 times 5. I get 15. This is a false statement, which means there's actually no solution to this equation. Every equation that we write does not necessarily have a solution. Some equations have multiple solutions, some have one, some have none. And this is an example. You could sit here all day and try to find a number and trial and error, try to plug numbers in here to plug into the left side and plug into the right side and make the both sides equal, and you're never going to get a solution. All right, our third equation. Oh, I look at that and I think, I wish that was a 4 because then I could do difference of squares. But unfortunately, this is not going to break down over the set of integers anyway. I'd have to use radicals just to break that down. So I'm going to multiply both sides through to, again, clear my fractions. So the least common multiple, there's nothing to factor here, so I would need to multiply both sides by x squared minus 2. And I would also need to multiply both sides by x minus 4. So now I'm ready to distribute. So I'll just cover that one up. So when I multiply this side, the x squared minus 2 cancels out that x squared minus 2, and I have negative 2. And normally I would distribute it through, but I'll just write it down this time. Okay, and on the right side, the x minus 4's will cancel, and then I'm going to have 2 times this factor. And once again, I usually distribute right away, but I'll just write down what I have, and we'll quick look at it again. So when I distribute this through to this left side of the equation, these cancel, left with negative 2 times x minus 4. When I distribute to the right side, the x minus 4's cancel, and I have 2 times this x squared minus 2. Okay, so let me distribute. So I have negative 2x plus 8. I have 2x squared minus 4. Now, this square is not canceling out, which means I know automatically I'm going to have to set this equal to 0 and either factor it or use quadratic formula. And I'm going to try to factor it. So I'm going to add 2x to both sides. So I'm going to write this guy down. I'm going to add 2x to both sides, so I'll have a 2x over here. I'm going to subtract 8 from both sides, and when I subtract 8 from both sides, I'm going to have a negative 12. Now I'm ready to factor, and I'm going to pull out that common factor first, because if this thing factors, it's going to be easier to see if I pull out that common factor. It's going to factor. I can see it now. X and X, I got a 3 and a 2. I have a plus and a minus, and I'm getting the right middle term. So I'm getting x is equal to negative 3 and 2. Now, we do have something that I haven't talked about yet. You've had these before. It is possible that when we go through the process of eliminating our denominators, it is possible to get an extraneous solution. And an extraneous solution is going to be a number that we think works. However, when we go back and substitute it back in, it ends up being something that does not work. And so we're going to quick check these. Sometimes these numbers that we get here can cause our denominator to have turned to 0 if we plug them in. Now, we don't have one that turns to 0. So neither one of these should be extraneous. Again, if one of these had come up a 4 or a square root of 2 or negative square root of 2, then those would be values that if I plugged them back into the original, they would not work. But if I take negative 3 and plug in, versus plug it in this side and see are they equal, this side becomes negative 1 and this side becomes negative 1. So we are good to go. I'm sorry, this is negative 2/7. We are good to go. And likewise, I could check them on my calculator pretty easily if I had a calculator to use. If I plug in, on the other hand, the positive 2, the negative 2 over the 2 squared minus 2, and 2 minus 4, plug those in, see if those are equal. This is the one that ends up coming up negative 2 over 2, which becomes negative 1, and this becomes 2 over negative 2, which becomes negative 1. So they do check. Okay, so that's the end of this video where we're just reviewing the idea of solving equations. You do want to check because occasionally extraneous solutions do come up.